All right, this is Math 103, and we're going to be talking about measures of dispersion, where 12.3 talked about measures of central tendency, and we were looking for that middle point. Measures of dispersion, we are looking for the variability or the spread of the data, okay? So we've got a few definitions that we have to write in here. This is used to describe the spread or variability of your data points, okay? And so they're all going to be varying around that middle point or the mean that we're going to be looking at. So we have three different types of measures that we're going to use. One is going to be the range. The other is going to be the variance, which we have to find the variance until we can find the standard deviation. Okay, so the easiest is the range. That is just the high score minus the low score, and that's all we have to do. So let's find the highest score first. So these are calories in different slices of pizza. So it looks like 320 is the highest, and the lowest appears to be 234. And so when I take 320 minus 234, I get a range of 86 calories. Then if we're looking for the range of camping tents, the lowest appears to be 60, and the highest appears to be 250. So 250 minus 60 is $190, okay? All right, so now when we go into finding the standard deviation, we've got this long process of finding it. And to start us out, we are going to make a 3-column chart. And so the first column is just going to be listing our data points that we call X. Then we're going to have our data minus the mean, or X minus X bar is going to go in the second column. And this is what we call the deviation. That's how far away that data point is from the mean. You can have negative numbers, negative numbers in this column, okay? So don't be alarmed if you get negative numbers. Then the last one, we're going to take the deviation that we found in the second column, and we're going to square it. So it's going to be X minus X bar squared. And these must be positive numbers only, because a negative times negative is positive, and a positive times positive is positive, okay? So after we create this column, we're going to list the data points. That's step 2, list the data points in the column marked data, and then we're going to find the mean of those numbers, okay? Then we're going to subtract that mean from every data value, and this again is called the deviation. Once you take that deviation, you're going to square each of those numbers and record it in the last column. And then you're going to sum, which means you're going to add up the deviations squared, okay? Or just put a note, add the last column, okay? You're going to get that number in step 6, and you're going to divide that sum by the number of data points that you have minus 1. So if you have 6 data points, you will divide by 5. If you have 8 data points, you will divide by 7. And this quotient right here is what we call the variance. And that's represented by, it looks like a cursive V. And last but not least, we are going to find the standard deviation, which is a lowercase sigma. And we're going to get the number that we found in step 7, and we're going to take the square root of it. So you're going to take the deviation squared divided by n minus 1, and then take the square root. So I know that looks very foreign to you. It's a lot of Greek letters, a lot of things that probably don't make sense right at the moment. But once we start doing this process, hopefully the steps will kind of become natural, okay? So we're going to do 3 examples. In this first one, we have the list of top 6 scorers of Cleveland Cavaliers and their heights. So the very first thing I'm going to do is just list those data points in the first column. Okay. Then I also like to make a note that n is 6, so my n minus 1 is going to be 5, which I'm going to use in this sum. Use later. Okay. Now, step 2, once I've listed all the data points, step 2 says that we're going to find the mean. So we're going to add all these numbers up, and then we're going to divide by 6. So when I add those up, I get 472 divided by 6 comes out to be 78.7. We'll just take it to 1 decimal place, and they'll usually tell you what to round it to, okay? Now I'm going to take every data point and subtract 78.7, and that gives me a negative 3.7. And then I'm going to square that negative 3.7 and write it here, 13.69. I'm going to do that for every one of those points. And I find it easiest to just work across so that you can just leave that number on your calculator and not have to clear anything out. So subtracting 78.7 from every data point, and then squaring that data point gives me 18.49 minus 78.7 gives me negative 0.7, and then I square that, and that gives me 0.49. Subtract 78.7, that gives me 2.3, and I square 2.3, which gives me 5.29. And last but not least, subtract 78.7, and that gives me negative 4.7, which then I square, and that gives me 22.09, okay? So now I am going to list or sum these numbers. So I'm going to now add up these numbers, and that gives me, I'm just going to put a plus there. So when I add that up, or the sum of the deviation squared gives me 65.34. Okay, and I now have to find the variance, and the variance is that number divided by n minus 1. Okay, so that comes down here. And when I take 65.34 and divide it by 5, I get 13.068. And I'm going to take it out a few decimal points. And now I'm going to find my final answer, which is sigma, and that is the square root of that last number. And so that comes out to be 3.61. So just to give you a visual, if you've ever seen a bell curve, okay, the mean is right in the middle, and that deviation, or that standard deviation, is going to say plus or minus up or down 3.6 inches from the mean. So all these, the majority of the point are going to fall within a little over 3.5 inches from the mean of 78.7, okay? All right, so let's start this next one. And we're going to follow the process again. So we're going to take, this one was 6 people were determined how much money they were carrying in their nearest dollar, to the nearest dollar. So we've got 32, 60, 14, 25, and they must hit a teacher on this one, $5 and 68, okay? So listing the points right off the bat, I also make a note that n is 6, so n minus 1 is going to be 5. Now I am going to find the mean by adding all of these numbers up, and that gives me 204. And dividing by 6 gives me an average of $34. So I'm going to take 34 and subtract it from each number. I'm tired of changing colors. And then I'm going to square it, and that gives me 4. Minus 34, that's 26. Squared gives me 676. Minus 34 is negative 20, squared is 400, minus 34 is negative 9, negative 9 squared is 81, minus 34 is negative 29, negative 29 squared is 841, and last but not least, 68 minus 34 is 34, and 34 squared is 1,156. And so now I am ready to add the last column up. And so I will get 3,158. So I take, to get the variance, I take that sum, I divide it by n minus 1, which is 5, and it comes out to be 631.6. And last but not least, I will find the standard deviation is the square root of 631.6, which is $25.13. Now, if they ask you to round to the nearest dollar, you would say 25. Okay, so that says that, you know, there's going to be plus or minus from the mean, which was $34, 25 up and down, you know, both sides, 1 or 2 standard deviations above or below that amount. Okay, all right. Now we will do the last one, and this is the lifespan of Labrador Retrievers. Again, we have 6 data points, so start with step 1. Let's list all those data points. And we're going to write n is 6, so n minus 1 is 5. So let's find the mean, and when I add these up, I get 72, and when I divide by 6, I get 12. Well, that's nice, no decimals to worry about. So subtract 12, I get negative 5. Negative 5 squared is 25. Subtract 12, I get negative 3. Negative 3 squared is 9. Subtract 12, get negative 1. Negative 1 squared is 1. Minus 12 is 3. 3 squared is 9. Minus 12 is 6. 6 squared is 36. Minus 12 is 0. 0 squared is 0. So now I will add these numbers up, and that gives me 80. And then I will find the variance is 80 divided by 5, or n minus 1, which is right here. And that gives me a variance of 16. And so the standard deviation is the square root of 16, which is 4. And that finishes 12.4 in Math 103.